Semics in Korea. Yes, please give Mr. Yu a warm welcome.
Good afternoon, ladies and gentlemen. My name is Shoun, the CEO of Semics. This is the last session today. Thank you for your persistence. You look like you need something that will cheer you up, and I brought them in myself. As you all know very well, the chalk and stage parts of typical prober is like this. Suppose this is a chalk where put wafers to be tested. The chalk moves left and right, back and forth by the XY stage at the bottom. And the chalk also moves up and down and rotate by Z and theta stages. I'll call these upper parts as chalk stage in this presentation. And my presentation is about introducing the new chalk stage. Many people take this configuration we see every day for granted. But I don't like this concept, and I believe it should be changed. In chalk stage, I believe chalk should have tilt movement function as well. Like our neck like this. Now I forcefully find my neck cannot go up and down. For me, the stupid thing I ever seen among what prober makers provide is top plate tilting option. Of course, we Semics also provide this, but it looks really stupid to me. I believe we should tilt the chalk, not the heavy and fixed top plate. The top plate is bound to the tester head working together with the prober. And the tester head is strongly fixed to the heavy manipulator that lies on the ground. This means we are trying to move a heavy thing bound to the ground. What a stupid situation. We should instead try to move the chalk which is lighter and not bound. This reminds me of a situation in archery. It would be ridiculous if the archer tried to move the target whenever he missed his shot. He should have more focus on aiming the target while he moves the target left and right. I believe chalk stage should have tilt movement function. Another stupid thing is also happening in chalk stage. I believe Z movement should be controlled based on force. But now we are controlling the height of chalk by position-based algorithm. I believe this is why we sometimes witness prober cut damage, which is very expensive. Even a blind can wipe the window glass safely, even if the position of the glass is not certain. This is because he controls his hands by force-based way rather than position-based one. Force control concept is just a common thing from long time ago, and it is not a leading-edge technology at all. However, why we break the window every time like this picture, only if the position is wrong just a little. This is really ridiculous to me. I believe the Z movement should be controlled by algorithm based on force. For my belief, I had tried many times to make a tilt movement function and force controlled Z movement for the chalk stage. However, all my trial had been failed. Chalk stage is very accurate and also a strong machine. The chalk stage is required 1 micron accuracy and over 300 kilogram load capacity. In order to keep accuracy and strength at the same time, I had believed each stage should have mechanism that allows only the major motion and all the other movements should be restricted. For example, Z stage should have linear guides to restrict all the motions other than Z, and the theta movement should be guided also by radial bearing. This was what I believe the only way to keep high accuracy and high load capacity at the same time. With this structure, the the only way we can implement tilt mechanism and force measurement unit is to put them in somewhere between Chuck zeta stage and Z stage, which are serially stacked one by one. However, Chuck stage cannot be bigger, and machine design is sometimes all about fighting with space. My first trial is trying to put small motor-driven tilt stage between the Chuck and the theta stage, but it was failed because that small mechanism comes from the limited space, could not meet the load specification required. My second trial was with piezo actuator. They are strong enough, but 5 centimeter piezo actuator, which would be the maximum length we can put in, can provide 30 micron stroke only. This is the law of piezo principle we cannot defy. I thought 30 micron stroke would be enough for compensating the planarity. But it was not actually, because the loss of stiffness comes from piezo actuator itself and the force gauge attached. We need more stroke for perfect compensation, so I failed again. I had made another few more trials, but they were also of no use. But one day, something happened. One of my top engineers came to my room. His name is Leo. He joined 쎄믹스 only 1 year before. At that time, that guy sitting over there, he proposed something. And he said, my dream would come true once he realized his proposal. The point of his proposal is like this. He proposed to boldly eliminate all the linear radial guides to restrict the unnecessary motions. Instead of serially accumulating each stage, he proposed to arrange 6 motor-driven actuators in parallel. And he combined those motions just through simple joint, and finally produces 6 degrees of motion. He asked my comment, but I felt a little jealous because he tried to do something I failed many times. So my comment was very negative. Come on, Leo. I have known this concept from 20 years ago. It is a technology used in articulated robot industry for a long time. It is 10 micron technology, but in proper applications, we need 1 micron technology, not 10 micron like in your concept. Major motions should be guided in order to achieve that high accuracy and that high load requirements. And I added, it looked not so strong and stiff to meet that harsh proper application. My final comment was that it looked so expensive. Maybe that narrow-minded Leo was damaged in the heart by my comment. He left my room, and from that time on, he never came to my room again. One day, maybe around 6 months after that incident, he finally appeared for revenge. He called me and asked me to come to his place, and I went there. He proudly showed me what he had developed after his proposal. It was like this. It moves up and down, and it tilted. It looked fantastic, but I still wondered whether this concept could be able to solve what was needed to fulfill my belief. I started to criticize his work again. This is 10 micron technology. That looks like high accuracy technology for prober. However, he showed me how accurate his chalk stage is by checking the accuracy himself. The accuracy data was like this. It was very good enough for proper application. I had no comment, but I realized it was accurate enough, but I could say nothing. After a while, I argued again that his chalk stage didn't look strong enough. Again, he proved his work by loading experiment at the site like this. I said nothing, but I realized it was strong and stiff enough for any proper application. I argued again by saying it looked so expensive. But he showed me the part list with price. I found it was reasonable. Then I tried more to discover final one-shot, one-kill question. I even raised the question about the lifetime data for that just-born machine. This way, the narrow-minded myself finally won the debate. Like this, Leo's fine work came to the world. Now I am very happy to see Leo's new chalk stage with chalk tilt function and force controlled G movement. But above all, I am happier to see his invention initiated other people in Semics to create several very valuable projects. 3 projects are about control system and algorithm, and the final is the machine development project for his own. The first project is perfectly aligned the planarity of the prober card with the chalk. At the same time, we'll keep the actual overdrive always the same. For this, we'll measure the force induced by prober card and adjust the center position of the force to the center of the prober card by using the tilt motion. After the project, prober card will be always safe because Z position is controlled by force. And above all, we don't have to wait until the height of the prober card is stabilized, even when the card is used in high work, cold temperature applications. In this way, I could dream the world where there were no such words like prober card damage and prober card soaking. The second control project is active stiffness compensation. In some applications, there are many cases where pin count is very high, but the produced force is not over the whole wafer. In this case, big force like a few hundred kilograms is induced to somewhere on the chalk, and consequently, the stage itself is deflected by the force. In this project, we are going to measure the force and move the chalk to perfectly compensate the deflection by all closed-loop control concept. The third project is for improving throughput by increasing the probing speed. The speed of prober is largely governed by the vibration it generates. The source of vibration is proportional to the mass of moving parts. By the way, Leo's invention is lighter than any other chalk stage in the world. So I'm expecting a far faster Semics prober through the successful finish of this project. In Semics, we have the whole name of all those projects I explained. I call them as the super contact project, meaning we are dreaming better contact than any other probers in the world through this project. The final project is the design of group testing machine for Leo himself. Increasing parallelism already has reached to one-shot probing, which is the limit. Instead of increasing parallelism, the industry is now trying to accumulate as many probers as possible in the given space. The key of the design is all about the size. However, his chalk stage has 6 degrees of freedom, meaning it can also move in X and Y directions as well. So huge XY stages can also be eliminated in memory one-shot probing application. So we are able to build a very small probing unit just to fit in the array type group testing machine. Another thing I want to emphasize is that this group testing machine is an array of real probers. To reduce the size, some group testing probers have probing units with instant vacuum contact concept. Sometimes they even eliminate the chokes, which I believe are crucial for reliable testing. I once called those simple concepts as eating junk food on the street. But I would call Leo's group testing prober as a fine food cooked by a great chef. But above all, I believe the most important contribution Leo's invention has made is to allow we Semics people to proudly devote ourselves to the noble purpose which Semics is pursuing. The statement of vision of Semics says, we Semics exist for providing differentiated machines to improve yield and convenience for our testing world. Leo created something for us to justify our purpose, and finally made us happy to devote to the project just to miss the reason why the world is a better place, because we Semics exist. Thank you very much.